Hi, my name's Kevin, and this is the third of the series which I'm doing on my machines which I've built so far. The first machine was a CNC router and also a CNC laser, which was both from my own designs, and you can see those in my other two videos. I'm now progressing into the world of 3D printing, and this was my first machine, which was just downloaded from the net, or the original plan was downloaded from the net, and has now gone through many iterations to get it to where it is now. The main thing, well, the main reasons really, do you know what, this is really hard trying to make videos. It's really hard. You've got to keep thinking ahead of what you're going to say, and I haven't got a script to go by or an auto cue, but anyway, keep persevering and we'll get there. Yeah, so as I was saying, this machine has gone through many changes. And the original machine, although it was very good, it had its flaws. I mean, it wasn't rigid enough, and also I wanted a slightly larger build volume for, for my particular things which I was looking at doing. So it went through many changes to get it where it is now. Originally, it had a Wade's extruder and was using 3mm filament, and although the Wade's extruder, it worked fine and I was happy with that, I just didn't like that look. It was a big clunky gear sitting there, and it just looked a bit sort of, I just didn't like it. So I swapped that out, redesigned all the extruder, and I've now gone to 1.75 filament and a direct drive stepper. And this is just a spare of the extruder, and I mean, the quality is very good on that now, and I'll show you some stills of those to the quality which is now printing at. Anyway, getting back to this, yeah, so that's pushing the filament through the extruder and then through the hot end. The hot end I'm using is an E3D. On this model is a V5, 1.75mm obviously. And then you've got your cooling fan here, just blowing on your part to cool it down as it's printing. I print with PLA. I do a bit of printing with ABS, but not too much. PLA is obviously a lot easier to get on with and whatever, and in a confined space you haven't got the worries about fumes and that sort of thing, so that's good. It's using a Ramps electronics hardware, and just it's just piggybacked onto a Arduino, and I'm using Marlin for the firmware, and that's pretty much it on there. The GT2 belts with GT2 pulleys. I've done away with the threaded rod. I mean, although that was okay, there was fluctuations. That's not 100% the thread running all the way up. It changes as it goes down. Sometimes you get a bit of a stretched thread and whatever. So that was causing me a few issues with like Z-band, and as the print was printing and that type of thing. So I'd done away with those and bought some of these proper threaded rods, which is the Acme rods. I had to think then, and also the nuts to go with those. So now everything's true. There's no play in there at all. That's all tight, and that's very good. Just running through normal linear bearings and obviously hardened chrome rods. And it's very good. The bed just runs on the same again, just on those chromed rods. I just got this machine. I use it occasionally, but I've now built another machine which is a far superior machine to this one. So this one doesn't really get so much use now. It's just sitting here. Anyway, I'll take a few close-ups of the machine just to show you, what it does actually look like and such, and you can see where I've changed these carriers. How complex they got, quite complex now to maintain rigidity, and then we'll move on to the new machine, and I'll show you the differences, the main differences, and then I'll also show you the print quality of what it's printing at now. Well, I hope you like those few stills there of just some of the models what I printed. They're just the ones what I just dug out of the box. I've done obviously a hell of a lot more printing than just those few items. I've done a few prototypes for people, and a few other things for other people. We've just done one which is now under patent, and we've now gone and taken that to injection moulders, and we're just having a small run of those done, and just to show some investors and that sort of thing. But the original prototype, or the original concept model, was done on this machine, and that come out really well. But you just can't. I mean, that's all right, these printers, but they're just so slow at printing. You can't do a production run. Not if you want to do a load. You can do 2 or 3, or you can do one-offs and that sort of thing. Whereas some of the prototypes, to do an ideal one-off prototype, just so an investor or a customer can get the feel of it in their hand, these are ideal. But when it comes to manufacturing, forget it. So that's why we've gone to the injection moulders to do a production run. This machine is far superior to the other machine which I showed you a little while ago. This one will print a lot faster, and is a lot more accurate, and the print quality is higher as well. It's got 2 heads, so it can print 2 different colours at once. I've been printing. The reason I wanted 2 heads was to be able to print PLA on one side and Flexi on the other side. So some of the models what I've done, they've had joints in, like an elbow joint, that type of thing. So I wanted the flexible joint in the middle. Well, I had to have twin heads for those. So that's working out quite well. It was a lot of setting up though, to get the oozing under control and that sort of thing. But once I got it sussed, it's working well now. So the twin head is a E3D Chimera. So it all comes under one block. So you've got two stepper motors at the top here, with its direct drive extruders, and obviously they're forcing the filaments down into the hot ends. On here as well, we've got auto bed leveling with a capacitive sensor here. That will detect the glass surface. Some sensors won't, but then these ones do. So you can get, so if your bed is slightly out or whatever, by the time it does its checking of the bed and where it is, and that the bed is exactly level to the heads. So that's a lot of headache out of the way, because that's one thing with these type of printers, is setting up the bed level and and that type of thing. So the machine itself is all aluminium box section, 20 by 20 extrusion, all bolted together, so it's really rigid. So here's the machine up close. As I explained, if I move this back, you can probably just see there's the twin heads sitting here. I've got the tubes coming over, the 2 reels that are on the back, where you can see where these are here. These are where the 2 PLA and the flexible sits on the back of the machine. They come over in the tubes into the direct drive, and then obviously forced into the hot ends down here. On the back of here, we've got the fan to keep the cold area cold, and that also obviously prevents the die swell of the PLA coming up back into the tube. Then on the back of here, we've got a cooling fan again, and that's blowing cool air down onto the part, not onto the hot end, actually onto the part, to keep it cool, and to cool it down during the print process. As explained, the machine is up here. We've got the adjustable tensioners. So I don't think I've seen that on a 3D printer up until now. So what happens is that, like during the summer and during the winter, obviously the aluminium, it may, you just don't know. It may expand and contract with it in the weather and that. So up here we can adjust the tension of the belts, and that's the same on all the axes. They've all got belt tensioners on. This machine, it doesn't run on the Ramps board. I've decided to go with the Rambo board for this particular machine. Just one of the reasons really was just that the control of the stepper motors is now done electronically, or on the software, rather than actually fiddling about with little trim pots, and that's made life easier for tuning the motors and things like that. Plus some of the other stuff in the Marlin firmware has been you know, so it's different to the ramp setup, so that's a lot better. Again, all these parts on here are all out of acrylic and all laser cut again, and obviously the frame is all housed within a acrylic frame as well. They just bolt onto the aluminium extrusion, and again, these have gone through sort of quite a few iterations to get those right, and get the tolerances nice and tight. This is the right hand side of the X carriage mount for the rods, and the adjustable belt drive as well, which you can see there, that's running through ball races. So just wind these screws in and out to adjust for tension and also for tracking. The wire rods backwards and forwards, they're just 8mm rods, but on the X carriage obviously there's a lot more weight there and a lot more inertia when the machine's operating, so these are 10mm rods to take that, and obviously to keep the machine still nice and true while it's printing. Well, here's the extruders here. Again, this is all my own design. You can see that the extruders aren't sitting flat onto the head itself. This is simply because I just couldn't get them close enough to be able to get the tubes to come into the Chimera. So I just had to twist them up and then obviously angle the tubes in, so I didn't get because the last thing I wanted was to get any binding and have any print issues. So what happens is now the PLA comes over the tube, straight into the cold end, forced through with the direct drive steppers, down into the tubes, straight down into the hot ends, and then obviously out the hot ends. So this has gone through quite a few variations and whatever, because I wanted to be able to keep it quite small to be able to get to my maximum widths, and as well as trying to keep it as light as possible. But it's working really well, and I'm really happy with that, and that's now come out really good. And obviously I never get any problems with any swelling of the PLA. I don't get no jams, obviously, because the E3D and hot ends and that, and that's really good. Here's just another view inside the machine. So again, just showing the head, and on the head here at the back we have optical sensors, so there's one on each axis, and that to enable it to come over and to auto home down to the bottom left corner. And then once a print is ready to be printed, you just load the print in, and the Marlin firm, or the software, has been told to take four registrations on the bed with the auto leveling sensor. So then if the bed is slightly not level, it will compensate for that once it's done its leveling sequence. So then once that's done, it comes over, purges the tip, and then goes off and starts to do its print. So what happens is that if the bed is slightly out of level, you can hear the Z-axis stepper actually winding as this moves across the bed, just to keep that level with the heads. So it's always level. That's a really good idea. I recommend anybody to do that. It saves all the messing about with bed leveling, which can be a pain on some machines. This just shows the full display graphic, what they call a smart display. So on here we have the temperature for 1 and 2 hot ends, so obviously left and right, and then we've got the fan and the speed at which the fan is controlling and whatever, and then obviously, but from this it can be tuned. You can actually tune while the machine is running, so you can speed it up, slow it down, you can force more PLA or more filament through the hot ends. You can adjust your jerk speeds and various other things, all done with this control panel, and obviously with the knob here. So we can go through the various things, and obviously the machine can print straight from an SD card. It doesn't need to be tethered to a computer. Well, I hope you enjoyed that. It's been really good. Well, I hope you enjoyed that. I've tried to explain, as much as I can, without going into too much detail and making it too long. If anybody's got any questions or whatever, they're more than welcome to ask, and I'll try my best to answer them. Like I say, 3D printers are still really just in their infancy at this stage. For this type of thing, I mean, I know, they've been used in the commercial world for many years, but for home users and that, they're just, in their infancy really, and that's only going to improve, and things are going to get faster, and print times are going to drastically reduce. I mean, there's just so much scope, and so much technology what's on the horizon. It's just a matter of the community just coming up with those things, and it won't be too long before there's going to be big changes in that. So, I understand some of the patents on particular things are coming to an end, which will then release people to bring new things to the market and various other things. And that's exciting times for that type of thing. So anyway, thanks a lot, and I hope you enjoyed watching the video, and I'll leave you with a clip of some of the items which have been printed on the new machine, as well as some other stuff what I've had sort of done, and what I've been messing around with. So anyway, thank you.